All right, hello everyone. I am Precious Ugweze. In this class, we're going to quickly look at the square root of surds. Okay, so if you have a surd, for example, let's say you have something like a, say, plus b root c, and you want to find the square root of this. So we said that to do this, all you need to do is to remark that if the sign you have here is positive, then equate that root to the square root of x plus the square root of y. You could use any other alphabet here depending on your choice. And so when you have done this, all you need to do is to solve this radical equation. Okay, in one of my videos we've talked about radical equations, and when you solve this radical equation, then your interest is to find the value of x and y, and which, when you have done that, just substitute it into this particular right hand side, and that will give you the required root that you are looking for. So now what if what you have is now a difference? That's, you have something like a minus b root c, and you're looking for the square root. So just the same thing you did here is what you would do. The only difference is that this will now be negative. That's minus root y. And then you are also trying to solve for x and y, and you put it here and you find the required value, the required root you're looking for. So quickly, we are going to look at some examples. So meanwhile, we have some examples here. It says find the square root of the following. I'm going to look at just the first one and the second one. So as a form of exercise, you will look at number 3 and 4, and you will get to show me what your solution is. Okay, so quickly let's jump into it. Okay, so here we begin with the first one. Here we have okay, so sorry, this is supposed to be 18 and not 17. Okay, so we have okay, sorry, we have 18 here. Okay, all right, so let's jump right into it. So we have 18 plus 12 root 2, and we want to find the square root. So like I said, all you need to do is tell us that the square root we are looking for, which is this, should be equal to the square root of x plus the square root of y. And now you are looking for x and y. So we are going to apply the process of solving when you have a radical equation. So I will square both sides, and if I square both sides, all that will happen now is that on the left hand side, the square will take away the square root, while on the right hand side we're going to expand this. So when we do this here, we're going to have 18 plus 12 root 2, and that is equal to, if we expand this, we're going to have the root of x plus the root of y, and you're squaring it, that's multiplying it by itself. And that is of course going to give us the square root of x times square root of x is x, and then square root of x times the square root of y is going to give us the square root of xy. And then we have, now we are done with this, so we go over to square root of y. Square root of y times this is also the square root of xy, and root y times root y will give us y. And then here, what do we have now? So we have that our 18. Now at this point, I can decide to bring in this 12 into the square root, and when I do that, that will give me 144 times 2, which is 288. So we have 288, square root of 288. Now we collect like terms here, and that's going to give us x. The rational parts, we bring them together, and then we gather these two, which are irrational, and that will give us 2 root xy. And of course, this is going to be 18 plus the square root of 288 is equal to x plus y. Now take these two also into the square root. That will give us the square root of 4xy. Now at this point we can now generate our equations using equality of sorts. You remember I said under equality of sorts that if these two sorts are equal, then 18 here must be equal to the rational term here, and then this radicand must be equal to the radicand here. So that is to say that x plus y must be equal to 18. I can call this equation 1, and then let's use this, and then our 4x must be equal to 288. I will not call this equation 2 because we can simplify it. And so if I divide through by 4, divide here by 4, so I'm going to get that xy alone is equal to 72. I can then call this my equation 2. Okay, so having gotten that, I can, from equation 2 as well, I can choose to do some further, breakdown. And what am I going to have? I can say let my y be equal to 72 over x. That is to say, I want to eliminate y when substituting into equation 1, and I can call this equation 3. So let's go down. Okay, so from now, I can substitute this equation 3 into my equation 1. Remember what equation 1 is. Equation 1 is x plus y is equal to 18. And now from equation 3, our y is 72 all over x. So that is going to give me 72 over x is equal to 18. So what do I do here? To take away this denominator, I will multiply through by x. And when I do that, I am going to have x times x is x squared. X times this will give me just 72 equal to 18x. Now I'm taking everything to this side. We'll have x squared minus 18x plus 72 is now equal to what? 0. And this produces a quadratic equation which we can solve by factorization to get the value of x. And so to factor this, I'm looking for two factors of 72 that will give me minus 18, and those are minus 12 and minus 6. So quickly just open your two brackets, x minus 12 into x minus 6 is equal to 0. So this implies that my x is equal to 12 or 6. So having gotten your x as this, remember that from equation 3, by equation 3, we have that y is equal to 72 all over x. So that is to say that we can find our y here by dividing 72 with x. So when x is 12, if you divide, it means that your y will be equal to 6. And when x is 6, your y will be 12. So you can then see that our square root, the root that we are looking for, is equal to the root of x plus the root of y. And so this is going to be, so when x is 12, so you have root 12 plus root 6. And when x is 6, you will also have this. So you just have this twice as your root, the required root that you are looking for. And that is the solution. Okay, so we'll quickly look at the example 2. And example 2 says that we should now find the square root of 8 minus 2 root 15. 8 minus 2 root 15. And let's quickly go to that. Example 2, the square root of 8 minus 2 root 15. Okay, and I want to use different alphabets here. I want to call it the square root of a. Remember I said when you have negative, it becomes minus the square root of b. And so we're going to square both sides, And when we square both sides, what are we going to have? The square root here will go. And so you have 8 minus 2 root 15 equal to the square of both sides here is going to be square root of a minus square root of b into square root of a minus square root of b. And so this is going to give us, okay, we can bring this into the square root, and that will give us 4 times 15, which is 60, is equal to, open this, you have a, this times this is minus root ab, this will also give you minus root ab, which is minus 2 root ab, and that is going to be minus root b times minus root b will be plus b. And so at this point, what are we going to have? So you can collect what you have here and bring these 2 into the bracket. So that's going to give us 8 is equal to the root of 60 is equal to a plus b minus 2 coming into here will give us 4ab. And of course, at this point, we can compare both sides. The rational part must be equal to this. The radicand must be equal to this. And so what will that give us? So we can have that this is going to be a plus b will be equal to 8 as equation 1. And then 4ab will be equal to 60, and from here I can divide through by 4, and that will give me AB is equal to 15, and I can call this equation 2. And from equation 2 you can quickly see that if we do exactly what we did initially, that our B is going to be equal to our b is going to be equal to 15 all over a, and then we can substitute this into equation 1. Remember that our equation 1 says that a plus b is equal to 8. Okay, so anywhere I see b now, I'll remove it and put 15, all over a. And so that's going to give me a plus 15 over a is equal to 8. Multiplied through by a, we'll have a squared plus 15 is equal to 8a. And then when we finally take everything to this side, we'll have a squared minus 8a plus 15 is equal to 0. And at this point, we can solve this quadratic equation, using factorization method. And when we do that, we're looking for 2 factors of 15 that will sum up to minus 8. And those are minus 5, and minus 3. Okay, so we can quickly bring them here. Open our two brackets here. We'll have a minus 5 into a minus 3, and that's going to give us 0. So that means a is equal to 5 or 3. Okay, and that being the case, please, when you are doing a subtraction, you are going to be careful. If it is addition, you're just going to have the same answer twice, but in this case it's going to be different, because when our a is 5, remember under here you have that b is equal to 15 over a. So when a is 5, b will be 3, and then when a is 3, b will be 5. And if you substitute that into the original equation we chose here, that's at this point where we decided to choose that our square root is going to be root a minus b. And so if you now substitute there, so you see that our square root, which is root a minus root b, is going to be, when a is 5, so you are going to see that you will have root 5 minus root 3, and or when a is 3, you will have root 3 minus root 5. And you can see these two are not the same. So these are the two roots of that given surd, which is 8 minus 2 root 15. Okay, so the square root of this is equal to this 2. All right, and you know that square root would usually produce 2 answers. Okay, that is the where we'll end it in this class. And please try to do the other two examples that you have, that's example 3 and example 4. Try to look at these two and drop your answers as comments in the comment section below. So that's where we'll end it for this class. Please kindly subscribe to our YouTube channel and have a great day. Bye.